1. What is database management system? Explain the advantages and disadvantages of DBMS. A database management system, DBMS, is a software application that enables users to store, manage, and retrieve data efficiently. It provides an interface between the users and the database, allowing them to interact with the data without worrying about the underlying complexities of data storage and retrieval. Advantages of DBMS. 1. Data centralization. DBMS allows for centralized storage of data, where all the data is stored in a single location. This eliminates the need for redundant data storage and ensures data consistency and integrity. 2. Data sharing and accessibility. DBMS enables multiple users to access and share data simultaneously. It provides concurrent access controls, allowing multiple users to work on the same data without conflicts. This promotes collaboration and improves data accessibility. 3. Data security. DBMS offers robust security mechanisms to protect sensitive data from unauthorized access and data breaches. It allows administrators to define user roles and privileges, implement encryption techniques, and set up access controls to ensure data security. 4. Data consistency and integrity. DBMS enforces data integrity constraints, such as unique keys and referential integrity, to maintain the consistency and accuracy of the data. It prevents data duplication, maintains data relationships, and ensures data quality. 5. Data recovery and backup. DBMS provides mechanisms for data backup and recovery. It enables users to create regular backups of the database, facilitating data restoration in case of system failures, hardware errors, or disasters. Disadvantages of DBMS. 1. Cost. Implementing and maintaining a DBMS can be expensive. It requires initial investment in software licenses, hardware infrastructure, and skilled personnel for administration and support. Small businesses or individuals with limited resources may find it challenging to afford a DBMS. 2. Complexity. DBMS is complex software, and its implementation requires expertise. It may require training and hiring professionals who are skilled in database design, administration, and programming. Dealing with the complexities of a DBMS can be challenging for non-technical users. 3. Performance overhead. DBMS introduces additional layers of abstraction and processing overhead, which can impact the system's performance compared to directly accessing data from files. Complex queries, high data volumes, or improper database design can lead to slower response times. 4. Single point of failure. If the DBMS encounters a failure or experiences downtime, it can disrupt the entire system's functionality. Without a proper backup and recovery strategy, data loss or system downtime can result in significant disruptions and loss of productivity. 5. Vendor dependence. Organizations using a specific DBMS may become dependent on the vendor for upgrades, support, and compatibility. Switching to a different DBMS can be challenging and costly, as it may require database migration and retraining of personnel. Conclusion. It's worth noting that while there are disadvantages associated with DBMS, the advantages generally outweigh them in most scenarios, which is why DBMSs are widely used in various industries and applications. 2. What is database model? Explain its types. A database model is a conceptual representation of how data is organized and structured within a database. It serves as a blueprint or plan that guides the design and implementation of a database system. Different database models have been developed over the years, each with its own approach to organizing and managing data. The choice of a specific database model depends on the requirements of the application and the nature of the data to be stored. Hierarchical database model. It is one of the oldest type of database model. In this model, data are represented in the forms of record. Each record has multiple fields or attributes. All records are arranged in database as tree-like structure. The relationship between the records is called parent-child relationship, in which one child record relates to only a single parent. Child possesses only property of a single parent. Here child are restricted to use the property of a parent to whom it doesn't belong. Advantages. It is the simplest and the easiest model. It supports one-to-one or one-to-many relationship. Searching is easier and faster if parent is known. Disadvantages. It is an old-fashioned and outdated database model. It doesn't support many-to-one relationship. It doesn't reduce data redundancy because some data are written over different places. Network database model. This network model replaces hierarchical model due to some limitation on the model. Suppose an employee relates to two different departments, then hierarchical model cannot be able to arrange record in proper place. So, network database model was emerged to arrange non-hierarchical database. The structure of database is more like graph rather than tree structure. A network model consists of collection of record which are interrelated to each other with the help of relationship. Each records have multiple fields and each field has only one data value. In this type of model, a parent may have multiple child, as well as child can have multiple parent. Advantages. It accepts many-to-many relationships. So, it is more flexible. It reduces data redundancy. This network mode is simple and easy to design. Searching is faster due to use of multidirectional pointer. Disadvantages. Needs long program to handle the relationship. Lack of structural independence. Less security. Relational database model. In relational database model, the data are organized into tables which contains multiple rows and columns. These tables are called relations. A row in a table represents a relationship among a set of values. Since a table is collection of such relationship, it is generally referred to the mathematical term relations, from which the relational database model derives its name. It is also known as RDBMS. Note, the database system which stores and displays data in tabular format of rows and column like spreadsheet is known as RDBMS. It is the most practical DBMS those days. For example, MS Access, MySQL, Oracle, etc. Advantages. There is less data redundancy. Breaking of complex database into simple is very much easier. Database processing is faster than other model. Disadvantage. Establishing more relationships complex. It requires powerful computer and data storage device. Object-oriented database model. The object-oriented database model, OODB, is a data management model that combines the principles of object-oriented programming with database management. Systems. In this model, data is organized and represented as objects, just like in object-oriented programming languages. Each object contains both data, attributes, and behavior, methods or functions, making it a self-contained unit that can interact with other objects through well-defined interfaces. Advantage. Redundant code can be eliminated by making use of concept called inheritance. Easy upgrading of a data system from small to large system. They can use more and more variety of data than other types of data model and also can access data much faster. Disadvantage. Poor performance in comparison to relational database model benefit is only on long run. This database model is very complex and it needs trained manpower to be operated. 3. What is SQL? Describe the types of SQL. DDL, Data Definition Language. A data definition language, DDL, is a subset of SQL, structured query language, that is specifically used for defining, managing, and modifying database structures. DDL statements are responsible for creating, altering, and deleting database objects, such as tables, indexes, views, and schemas. Unlike data manipulation language, DML, which deals with querying and manipulating data within tables, DDL focuses on the database's structure itself. Some commonly used DDL statements include 1. Create, 2. Drop, 3. Alter. Creating a database, syntax, create database _name, example, create database school. Dropping the database. Syntax, drop database _name, example, drop database school. Creating a table syntax, create table _name, column _name 1 data type, length, column _name to data type, length. Column _name _ in data type, length. Example, create table students, SID int primary key auto _increment, name varchar, 255, address varchar, 255, class int, date of birth date, output, SID name address class date of birth. Dropping table syntax, drop table _name, example, drop table students. Alter to add new column syntax, alter table _name, add column _name data _type, example, alter table students, add column phone double, output, SID name address class date of birth phone. Data manipulation language. Data manipulation language, DML, is a subset of SQL, structured query language, that deals with querying and manipulating data within the database. Unlike data definition language, DDL, which focuses on creating, modifying, and deleting database objects, DML is concerned with the actual data stored in the database. DML statements allow users to perform various operations on the data, such as inserting, retrieving, updating, and deleting records in the database tables. Some commonly used DML statements include 1. Insert 2. Update 3. Select 4. Delete. Insert, used to add new records, rows, into a table. Syntax, insert into table _name, column 1, column 2, column 3, values, value 1, value 2, value 3. Example, insert into students, SID, name, address, class, date of birth, phone, values, 4, Ashok Dangol, Tokha 3, 12, 2047-0904, 9846262805. Insert into students, SID, name, address, class, date of birth, phone, values, 10, Anuj Thapa, Novakot, 12, 2045-0504, 9846262805. SID name, address, class, date of birth, phone 4 Ashok Dangol Tokha 312 4th September 2047 9846262805 10 Anuj Thapa Novakot 12 4th May 2045 9846262805. Update, used to modify existing records in a table syntax. Update table _name set column 1 is equal to new _value 1. Column 2 is equal to new _value 2 where, condition. Example 1. Update the address to Kathmandu and class to 11 whose SID is 4. Update students set address is equal to Kathmandu, class is equal to 11 where SID is equal to 4. SID name, address, class, date of birth, phone 4 Ashok Dangol, Kathmandu 11 4th September 2047 9846262805 10 Anos Thapa, Nuwakot 12 4th May 2045 9846262805. Example 2. Update of phone no to 984 crores 12 lakhs 34,567 whose name is Anos Thapa. Update students set phone is equal to 984 crores 12 lakhs 34,567 where name is equal to Anos Thapa. Select used to retrieve data from one or more database tables. Syntax select asterisk from table underscore name. Example 1. Display all the records from table students. Select asterisk from students. Example 2. Display name and class of the records from class 11. Select name, class from students where class is equal to 11. Name class Ashok Dangol 11. Example 3. Display all the records from table students who address start from K character. Select asterisk from students where address like K%. SID name, address, class, date of birth, phone 4 Ashok Dangol, Kathmandu 11 4th September 2047 9846262805. SID name, address, class, date of birth, phone 4 Ashok Dangol, Kathmandu 11 4th September 2047 9846262805 10 Anos Thapa, Nuwakot 12 4th May 2045 9841234567. SID name, address, class, date of birth, phone 4 Ashok Dangol, Kathmandu 11 4th September 2047 9846262805 10 Anos Thapa, Nuwakot 12 4th May 2045 9841234567. Example 4. Display name and phone from table students. Select name, phone from students. Name, phone Ashok Dangol 9846262805 Anos Thapa 9841234567. Delete used to remove records from a table. Syntax delete asterisk from table underscore name where condition. Example 1. Table before deletion. SID name, address, class, date of birth, phone 4 Ashok Dangol, Kathmandu 11 4th September 2047 9846262805 10 Anos Thapa, Nuwakot 12 4th May 2045 9841234567. Delete asterisk from students where SID is equal to 4. SID name, address, class, date of birth, phone 10 Anos Thapa, Nuwakot 12 4th May 2045 9841234567. Data Control Language. Data Control Language (DCL) is a subset of SQL, structured query language, that is used to control access and permissions in a database management system, DBMS. DCL commands enable database administrators, DBAs, to define and manage the security and access rights for database users and roles, ensuring that data remains secure and protected from unauthorized access or modification. The two primary DCL commands are grant. The grant command is used to give specific privileges or permissions to database users or roles. These privileges can include the ability to perform actions like select, insert, update, delete, or execute on specific database objects, such as tables, views, or stored procedures. By granting appropriate privileges, the database administrator can control what operations users are allowed to perform on the database. Revoke. The revoke command is used to revoke or remove previously granted privileges from a user or role. This command allows the DBA to modify access rights and restrict certain operations that were previously allowed. 5. Differentiate between centralized database system and distributed database system. Centralized database. Distributed database architecture. In a centralized database system, all the data is stored in a single location or server. It follows a client-server architecture, where multiple client applications connect to the central database server to access and manipulate data. In a distributed database system, data is distributed across multiple locations or servers, often geographically dispersed. The system follows a distributed architecture, and different portions of the database may be located on different nodes. Data control, the database, administration, and management tasks are concentrated in one central location. Database administrators have full control over the entire database, including data security, access control, and backup procedures. Database management tasks are distributed among multiple nodes. Each node may have its local administrator responsible for managing its portion of the database. Data replication and synchronization become critical in ensuring data consistency across the distributed environment. Performance: since all data resides in a single location, queries and transactions can be processed relatively faster due to lower data access latency. However, heavy load or bottlenecks on the central server can affect overall system performance. Distributed systems can potentially offer better performance and scalability since data can be accessed locally from the nearest node, reducing data access latency. Parallel processing capabilities can improve query performance. Data integrity: centralized systems can enforce strict data integrity constraints more easily since all data is managed in one place. Maintaining data. Ensuring data integrity in a distributed system is more complex compared to a centralized system. Synchronization and replication. Consistency and ensuring referential integrity is generally simpler. Mechanisms are required to maintain consistency across multiple nodes. Scalability: scaling a centralized database system can be challenging, especially as the volume of data and user requests increases. The central server can become a performance bottleneck as the system grows. Distributed databases are more scalable than centralized ones as they can handle increased data volumes and user requests by adding more nodes. Horizontal scaling: adding more nodes is often easier to achieve in a distributed environment. Conclusion: choosing between a centralized and distributed database system depends on various factors such as the scale of the application, performance requirements, data distribution needs, fault tolerance, and budget considerations. Centralized systems are generally simpler to manage but may become a single point of failure and have limitations on scalability. Distributed systems, on the other hand, offer better performance, fault tolerance, and scalability, but their design and maintenance can be more complex.